To relate force and potential energy, and to relate electric field and electric potential, we're going to be using something called the gradient, which is represented by this symbol here. It looks like an upside down triangle, but it's pronounced del, or the actual name for the symbol is nabla. But anyway, for us, when we see this symbol, we'll read it as gradient. So I'd read this equation as force is equal to the negative gradient of potential energy. And I'd read this equation as electric field is equal to the negative gradient of electric potential. So that's where the gradient will appear for us, but what does it actually mean? Calculating the gradient is a way to determine the components of the vector, whether that's the force or the electric field, on the left-hand side of the equation. And to do that, what we'll do is calculate the partial derivative of the function in each of those directions. So for example, if I wanted to find the electric field in the x direction, I take the negative partial derivative of my electric potential with respect to x. If I wanted to find the electric field in the y direction, I take the negative partial derivative of my potential with respect to y. And in terms of calculating this, if you were given a picture of the equal potential lines, you could find this as the negative change in potential per change in distance. So again, a partial derivative is just like a regular derivative, it's just a bunch of changes. So we can approximate this as change in potential per change in x times the negative. Now, we might also see the word gradient used in a sentence. So for example, the sentence, a gradient in the electric potential causes charges to move from regions of high potential to low potential, simply means a difference in the electric potential causes charges to move from regions of high to low potential. And again, that goes back to this definition here of our gradient just means take a negative, or a negative gradient means take a negative partial derivative with respect to a distance, and if there's a change in our electric potential for this example, then we would have an electric field.